Okay, so today we are going to be multiplying polynomials. Last week we added and subtracted, and now we're going to take it to the next level. So we're multiplying powers of the same base. In just a second, I'll describe what that means. You're going to multiply the coefficient, so the word multiply goes in this spot. And you're going to add the exponents. So when I have something like x to the fourth power, this right here, the x is called the base, and this right here is the exponent. And of course, if I have a number in front of the variable like a 5, this is the coefficient. Okay, so whenever you're multiplying something like this times something else, you're going to multiply the coefficient, keep the base the same, and add the exponents. All right, here's a generic example of how x to the m times x to the n. I'm going to add the m and the n. They have to have the same base in order to do this. If it was an x and a y, I could not multiply. I could multiply, but I could not add the exponents. Okay, so this first example, x squared times x to the third power. I'm going to add the 2 and the 3, so my answer is x to the power of 5. The reason for that is because x squared means I have 2 x's, and x to the third power means I have 3 x's. Remember, exponents tell you how many times you see that base. So if I have 2 x's and 3 x's, you have a total of 5. That's why we add them. It sounds kind of confusing because you would think you would multiply the 2 times the 3 because it's a multiplication problem, but you're actually adding the exponents, and this is the proof as to why. The next example, we have 4x cubed times 2x cubed. I'm going to go ahead and take the 4 and the 2, and I'm going to multiply those two together. That's going to give me 8. And then I'm going to x to the third power and x to the third power. I'm going to take those powers, the 3 and 3, and I'm going to add them. So my answer is 8x to the power of 6. Again, you're going to multiply the coefficients, add the exponents. Over here, x to the fifth times x to the third power. I don't have a coefficient here, so I'm just going to add the exponents, x to the power of 8. 2x cubed times 2x squared. I'm going to multiply my coefficients. 2 times 2 is 4. Write your base x. I'm going to add the 3 and the 2 for x to the fifth power. And then last over here, 6x squared times negative 3x to the fifth. 6 times negative 3 first, negative 18. And x to the second power times x to the fifth power. I'm going to add the 2 and the 5. To get a power of 7, or an exponent of 7. Some of you may question, why am I multiplying the coefficients but not multiplying the exponents? The reason being is because your coefficients, you know what they are. I know what 6 times negative 3 equals. But when I multiply these x's together, I have no idea what x equals. So I can't multiply them. I'm going to simply just use the rules of adding those exponents, because x squared means I have 2 x's. And x to the fifth means I have 5 x's, and so I have a total of 7. Okay. In this next section, we're going to multiply, just using the distributive property, and this time we have variables on the outside, not just a number. Same process. I'm going to take what's on the outside of the parentheses and multiply by the 6x and the positive 6. Keep in mind, you're going to add the exponents together. So 8x times 6x. I'm going to multiply 8 times 6, that's 48. X times x, that's x to the power of 2. And some of you are like, well, how does that happen? Because x times x means I have 2 of them, so that means I have x squared. Then I'm going to multiply 8x times positive 6. 8 times positive 6 is a positive 48. And I'm going to attach the x. Since there's not an x over here, I don't need to change the exponent. Just 48x. Just below that, negative 2x times 3x squared minus 4x plus 5. I'm going to distribute the negative 2x to each one of these. Again, I'm multiplying the numbers in front, the coefficients, and then if they have any variables, I'm going to add the exponents if they have the same base. So negative 2 times 3, negative 6, x times x squared. That's going to be a total of 3 x's because you have 1 here and then 2 more here. So x to the power of 3. Then negative 2x times negative 4x. Negative 2 times a negative 4 is a positive 8. X times x, that's 2 of them. So I have x to the power of 2. And then finally, negative 2x times positive 5. I'm just simply going to multiply negative 2 times 5, which is negative 10, and attach the x to the end of that. Again, multiplying the coefficient, or the coefficient times the constant. If it has the same base, you're going to add the exponents. Last one in this row, 3n times n squared. 3, that's a 1n squared. We put a 1 in front of it. 3 times 1 is 3. N times n squared, that's 1n, and then 2 more, so we have a total of 3. So n to the power of 3. 3n times negative 6n. Keep in mind, that's a negative 6. If I were to cover this part up, that's how I would read that. If I uncover, I say minus. If I cover, I say negative. They both mean the same thing. 3 times negative 6, negative 18. And then I have an n, another n, so I have n to the power of 2. And then finally, 3n times positive 5. I'm going to take that 3 times the 5, which is a positive 15, and then simply attach the n to the end of that 15. Okay, the next section, we're going to do these 3. So 7n times 6n. Again, I multiply 7 times 6 because I know how to do that part. 42. N times n, that's 2 of them, so n to the power of 2. Then 7n times positive 3. 7 times 3 is a positive 21. Attach the letter n to that. So the answer is 42n squared plus 21n. I have 3x times 2x squared first. 3 times the 2, 6, x times x squared, that's 3 x's all together, so x to the power of 3. Then I have 3x times negative 5x, 3 times negative 5, negative 15, x and x make 2 of them when you're multiplying, so I have x squared. And then last, 3x times positive 7 will give me a positive 21x. All right, last one in this row, 2k to the third power, first times 2k to the second power. Multiply your coefficients, 2 times 2. K to the third power times k to the second power. I'm going to take those exponents. Remember, this is 3k's times 2, or times 2 more, so that's a total of 5k's. Again, a common mistake kids do is to multiply the exponents, but the rules say you need to add. Then I'm going to multiply 2k to the third power times 5k. 2 times 5 is 10. There's 3k's here, and then 1 more, so I have k to the power of 4. And then last, 2k to the third power times negative 4. 2 times negative 4 is a negative 8. And simply attach the k to the third power. All right, I want you to try these 3 here. I'll give you a few minutes, and then we'll go over the answers in just a moment.